but as you'll see as I go into the talk, I owe a great deal to her, although I have some points of disagreement as well as agreement, and I'll talk about those too. Well, many people in SPRU and in Centrum have been described as Schumpeterian, and we're used to this description that we are either Schumpeterians or neo-Schumpeterians. Well, this doesn't mean, of course, that any of us subscribe to all of his ideas. Far from it. But what we probably all share with Schumpeter is a belief that technical innovation is central to social and economic development, and that it's extremely important to study it and understand it. There is a crude summary of some of Schumpeter's key ideas. He never had very much to say about science or invention. Innovation was always the center of his work. He was just as interested in organizational, financial, and managerial innovations as he was in technical innovations. In fact, there's more about those in his book on business cycles than there is on technology itself. He had this notion, which marks him out for almost anyone else working in the field, that innovation was not an act of intellect, but an act of will. In other words, he thought the entrepreneur, later called the product champion, was the key individual in the process. And it was the entrepreneur's determination to see through a new product or a new process against all the odds, often against considerable hostility and criticism. This was what was decisive in Schumpeter's theory for innovations to succeed. Diffusion, although he certainly paid attention to it, and although he was responsible for the division which we all use to some extent between invention, innovation, and diffusion, diffusion, like invention, occupied a somewhat lower place in his scheme of things than innovation itself. And sometimes he talks about mere followers, about routine managers and imitators. At other times, he's not always completely consistent, as none of us are. Schumpeter does recognize that an innovation like the automobile changed enormously from the early days to the final models, or the later models of the 1920s, 1930s, so on. But in general, he downplays the diffusion process compared with the original innovation, which he regards as the driving force of economic development. From Marx, he took the idea of the erosion of profits during the diffusion process, and that plays a very important part in his theory of business cycles. The idea of Condrative cycles, that is roughly half-century cycles of economic change and development, he took from the Russian economist Condrative. Condrative himself wasn't the originator of the idea. In fact, a Dutchman called Van Gelderen actually was one of the first, if not the first, to give a systematic exposition of long cycles of economic development. But Van Gelderen had the misfortune to write entirely in Dutch, and so neither Condrative nor Schumpeter was aware of his work, which was published already before the First World War in 1913. Well, the notion of uneven growth of leading sectors of the economy and of an economy driven by innovation, Schumpeter took largely from Marx. There were two big influences on Schumpeter's intellectual development. One was Marx and the other was Walras. Two very different types of theorists. And there was a very uneasy coexistence of these two theories in Schumpeter's mind and in his work. Some people say, for example, Rosenberg says, that Schumpeter wasn't all that serious about his tributes to Walras. And people are still arguing about that, as they still argue about quotations from the Bible. You can find quotations to prove various different interpretations. But personally, I agree with those people who think that Schumpeter never quite reconciled Walrasian and Schumpeterian or neo-Marxist ideas. That on the one hand, he often says that capitalism is in a continual process of turmoil, of change, development, and there never is an equilibrium. At other times, even to the end of his life, he was saying that Walras and the Walrasian model of static equilibrium was the greatest achievement in economic theory. From Marx, Schumpeter took the notion of a system driven by innovation, and he took the idea that the capitalist system was inevitably driven towards constant turmoil because those firms which didn't innovate when their competitors did would sooner or later be driven to the wall. He took from Marx too the idea of a temporary rent or super profit to be made from successful innovations, and the idea that those temporary rents or extra profits would be eroded through the diffusion process of imitation. Finally, he took from Marx the notion that competition would lead to concentration of ownership, to the growth of large firms and monopoly. The notion that that process would lead to long cycles of economic development depended on his belief that innovations are unevenly distributed both in space and in time. And to my knowledge, nobody has refuted either of these central propositions of Schumpeter. He argued, and you can check this in any industrial history or economic history, he argued that innovations are not distributed evenly over every branch of the economy, but on the contrary, they tend to cluster or concentrate in certain sectors, which are then the leaders in spurts of growth in the economic system. Similarly, if we take the time dimension, innovations are not evenly spread over time. They're also bunched and clustering at different phases of economic development. And finally, he argued in his book on business cycles, which he regarded as his magnum opus, although it wasn't so well received by the economics profession, he argued that those processes of clustering of innovations, of uneven growth of industries over different historical phases, that they gave rise to a disruption of the existing economy and to processes of what we now call structural adjustment to the rise of those new industries and technologies. Well, the fact that he regarded cyclical movements as repetitive and that he expected further cycles to continue into the future, although not to the indefinite future, the fact that he thought of cycles as a regular occurrence within a system driven by innovation does not mean that he didn't recognize differences between cycles. On the contrary, he emphasized very strongly the individual character of each cycle, the special features of each cycle, and the need to study the special characteristics of each and every one. So he would go along with Popper in saying that history is a unique process and must be understood as a unique process. The archetypal example with which he begins the historical section of his work on business cycles is, of course, the British Industrial Revolution. And this isn't his statistics. This is a more recent source in 1994 Crofts. It's revised estimates of the growth of different industries in the British Industrial Revolution. But what's quite clear from the revised figures or from the older figures the British Industrial Revolution was characterized by an extraordinarily rapid growth of the cotton industry. Of course, that's schoolboy stuff. Everybody used to learn it at school. I don't know whether they still do. But at any rate, in my day, everyone had to learn about Arkwright, Crompton, Roberts, etc. And it can be justified because growth rates of 6 to 13% per annum over a 30 or 40 year period are very high growth rates, even by modern standards. That rate of growth, 6 to 13%, also characterized the growth of railway freight and passenger traffic in the period of the 1840s to the 1870s. It characterized the growth of the steel industry in the 1870s to the 1900s. It characterized the growth of the oil industry and the automobile industry later on. And finally, of course, microelectronics has grown even faster than that, but various branches of the electronic industry and the chemical industry show quite a respectable rate of growth if they achieve between 6 and 15%. So this was the first big example of a huge spurt in the growth of a particular industrial sector. The iron industry was also, of course, extremely important, although nothing like so fast growing as the cotton industry. Schumpeter, like most authors, attributed, of course, the growth of the British cotton industry to a cluster, a concentration of inventions and innovations. And again, that orders of magnitude improvement in labour productivity is comparable to some of those increases achieved much later in the 19th and 20th centuries. And you'll see that by far the greater part of the improvement in labour productivity actually occurred before 1825. So it was a really tremendous spurt, and it's not surprising it made a tremendous impact on observers at the time and historians ever since. And of course it led not only to the success of the British Industrial Revolution, but to the ruin of older industries in India, other parts of the world, and I heard when I was in Denmark last week, it also led to the ruin of the textile industry in the Faroe Islands. So it had very widespread effects throughout the world economy and not only in Britain. Schumpeter argued that those leading sectors could only have grown as tempestuously as they did if they had, because they enjoyed a similarly rapid growth of a new infrastructure, transport infrastructure and energy infrastructure. This graph, again, it's not from Schumpeter himself, but it shows the extraordinarily rapid growth of turnpike roads and canals. This is before the days of railways. And the turnpike roads and canals had a growth of about 6 or 7% per annum, which made it possible for the changes which Adam Smith had envisaged in 1776 to take place, i.e., the sweeping away of barriers to internal trade, the extremely rapid growth of the movement of goods and people over the whole of the British Isles, and the unification of the British market so that the producers of cotton goods or of iron goods could enjoy a very large internal market. So this was the basic idea which Schumpeter put forward in his business cycles, but he departed from Condrative in one very important respect in his theory of infrastructures. Condrative, in his work in the 1920s in Russia, had argued that investment in infrastructure was the driving force of what became known as the Condrative Cycles, of the long waves of economic development. And Condrative argued that the reason that these cycles lasted approximately half a century, 20 to 30 years of growth, 20 to 30 years of slower growth or stagnation, that the reason for that cyclical movement, according to Condrative, was the need to replace the fixed investment of the infrastructure. It was a replacement cycle for long-lived structures. Schumpeter didn't accept this theory. He argued that it wasn't a question of replacement of an old infrastructure that might or might not take place. But what was important was the rise of new infrastructures. So it wasn't a question of replacing canals, although that may have taken place. It was the rise of the railways, which was the next big new infrastructure, which was important in Schumpeter's scheme. And similarly, it was the rise of electricity and of later road highways, which were important in later cycles. You can see this especially well in the case of electrification. This overhead shows how most American households and American factories were wired up, connected to an electric power system in the period between 1890 and 1940. And that electrification, Schumpeter argued, a big infrastructural investment in itself, a massive source of growth, but it more importantly made possible the application of electric power in numerous other industries across the whole economic system. And that electrification of other industries, the introduction of electric power tools, machine tools, electric drive in all kinds of factory systems, plus the electrification of households, the availability of electricity-based consumer durables, that was a huge source of new growth throughout the economic system. This is how he describes, in a rather stilted way. Unfortunately, the style of his books was never all that clear. But this is how he described the effects of electrification, which is usually called by him and his followers the third Condrative wave from the 1890s to the 1940s. And you'll see he emphasizes that electricity provided a unifying tendency for the whole of economic development. Leslie Hanna, who works at LSE on the history of firms, put the point more briefly and I think more effectively in his comparison with microelectronics. Simply the transforming power in the home, the factory, urban public transport throughout the economy of a revolutionary new technology. Another Nelson, not the Dick Nelson that we all know, but an historian in the United States, pointed out that electric power, and many historians of course have said the same thing, electric power made it possible to reorganize factories in every branch of the economy. You could get rid of all the mechanical belts, you could have unit sources of power for machine tools and other machines, you could have far better layout of factories, and there were big capital savings from that renewed layout of factories. And this introduces a very important aspect of Schumpeter's theory of long waves, that they depended not only on technical innovations and infrastructural innovations, but also on organizational and managerial innovations. People disagree about the relative importance of these things and whether the organizational innovations are driven by the technology or vice versa, or as I would maintain, that they inevitably accompany each other. Because you cannot have a new process, a new way of running a factory without changing the organization and the skills in that place of employment. Well, it was the rise of electric power in the end of the 19th century and the beginning of the 20th century which really first generated interest in the idea of long cycles of economic development. And the early pioneers of long wave theory, before Condrative or Schumpeter began to write about them, they were quite a mixed bunch. Some of them were the leaders of neoclassical theory. Pareto wrote quite a lot about long waves, including some very interesting ideas about political changes during long waves. Jevons took the idea of long waves very seriously and wrote mainly about the price fluctuations during the long cycles of development. Also, there were monetary economists who took the idea very seriously. And finally, there were Marxist economists, and two of the best known were Parvus, who worked both in the German Marxist movement and in the Russian Marxist movement. He had a very strange career. One of his last operations was to arrange for Lenin to return to Russia in April 1917 by negotiating it with the German General Staff. So he was a Maxwell of his day in some ways. A very strange chap who had contacts with various intelligence services. But never mind, he wrote some very interesting things about long waves. And Van Gelderen, the Dutchman whom I mentioned, was another of the early pioneers, writing in 1913, as I said, in Dutch. He introduced the notion of spring tides and ebb tides in the development of the economy. And he was very strongly influenced by the huge surge of investment in electricity generating and distributing systems in the early part of the 20th century. And that very briefly summarized how he contrasted spring tides of economic development with the ebb tides, the kind of thing we're living through now. He would have recognized quite well as an ebb tide, high unemployment, very much reduced inflation, depressed conditions generally, and slackening of investment behavior. Well, this table is neither from Schumpeter nor from Van Gelderen, it's my own, and I'm using it to introduce the key features which, although both Van Gelderen and Schumpeter would not accept all my terminology or my dates, nevertheless, I think, fairly characterize the general approach which they're made. And you'll see that two of the, what I call, or what Carlotta called, the carrier branches of a long wave, I've ringed around in red. Steam engines in the second Condrative wave, automobiles in the fourth Condrative wave. And the reason I've ringed them round is that they don't correspond to Schumpeter's designation. Schumpeter put steam engines in the first industrial revolution. He thought that steam engines belonged to the early period I was talking about of industrialization at the end of the 18th and early 19th centuries, when indeed Boulton and Watt had begun to design and sell their steam engines. So Schumpeter put steam engines in that first and not in the second wave. He also put automobiles in the third Condrative wave, arguing that automobiles and the oil industry already had grown very fast in the period between 1900 and 1929. The reason that I've put them in a different wave is to do with what is responsible for a Condrative wave. According to Schumpeter and some of his followers, the stress was mainly on the early innovations. From my point of view, what causes a big disturbance in the economy is not the early innovations, but the widespread diffusion of products, services, and technologies. That's what has the big effects on the economy as a whole. So from my point of view, I agree here completely with Nick von Tunzelman in his book on steam power and British industrialization, where Nick points out that the steam engine only became a general source of energy in British manufacturing in the middle and latter part of the 19th century. And relatively few steam engines were actually used in the early part of the Industrial Revolution. Water power was still the main source of energy at that time. Similarly with automobiles, the expansion of the oil industry to about a couple of billion barrels of crude oil per annum took place in the 19th century in the United States. But the expansion from 2 billion to 20 billion tons of barrels of crude oil took place between 1940 and 1973. And that's when oil supplanted coal as the main source of energy worldwide in industry. So from my point of view, oil and automobiles, some people have called it a Fordist mode of production, belong to the fourth Condrative, to the post-war boom, rather than to the third, where Schumpeter placed them. Well, this leads directly to disagreements with Schumpeter's theory of long waves. And these are the problems with his theory that I want briefly to discuss. All of them were raised by his critics, especially by Kuznets, as long ago as 1940, a year after his Business Cycles book first appeared in the United States. But all of them, I think, merit serious discussion and have never really been answered by him or by his immediate followers. Rosenberg, in his contributions to the debate on long waves, raised virtually the same criticisms 30 or 40 years later. The first point, Kuznets said, well, some innovations are quite important, like railways, but even the biggest innovations are not enough to cause fluctuations of that duration throughout the entire economic system. Second point, which I raised already, he said, does Schumpeter suggest that long waves are driven by the original innovations or by the diffusion of innovations? And if by diffusion, as Kuznets thought far more plausible, if by diffusion, then what period of diffusion? Early diffusion, middle diffusion, late diffusion. Thirdly, Kuznets queried Schumpeter's account of the lower turning point, the movement from the trough of a depression to the new upswing. And Kuznets argued that if Schumpeter really believed that it was heroic entrepreneur that drove the whole cycle, then did they get tired every 50 years? Why didn't they keep on innovating all the time? So those were the kind of criticisms that were made of Schumpeter's theory already in 1940. But of course in 1940, the Second World War had broken out, and Keynes had written his general theory of employment, interest and money, and Keynesian theory, partly because of the Second World War, became extremely influential throughout the industrial countries. Keynesian theory not only was rather successfully applied in organizing the British war effort, it was also applied in different ways in other countries in the war period itself, and even more in the post-war period. And it's difficult to convey this now, but in the 1950s and 1960s, the economics profession generally tended to assume that the problem of mass unemployment had been solved, that it would not recur, that Keynes had shown the way to overcome, if not completely, then to a high degree, the cyclical fluctuations in the economic system. And it was relatively rare for people to disagree with this analysis of Keynesian economic theory and policy. Some monetarist economists, of course, always disagreed with it, and some other economists did. But generally, it was an orthodoxy that was very influential indeed. Well, the new debate on long waves, therefore, was very retarded, because most people thought even if long waves had existed, they were a thing of the past, and we didn't have to worry about them now. One of the first economists to query this general orthodox assumption was Ernest Mandel, the professor of economics in Brussels University, and as early as 1968, and more frequently in the 1970s, he raised again the whole issue of long waves, and he argued that the period of dramatic post-war growth of about 4 or 5% per annum in most countries, which had gone from 1946 or 7 right through to the late 1960s, he argued that period was coming to an end. And of course he was right. He said later that he stood on somewhat lonely ground, and he was fully justified to say that, because most people ridiculed it when he said that we were now entering a new period in the OECD economies of much slower growth, of higher unemployment, of lower capital productivity, and generally of a structural change. Well, although he was alone in the early 1970s, soon, of course, and especially after the OPEC oil crisis of 1973, many other people began to realize that something was changing in the way the world economy was evolving. In 1975, a German economist called Gerhard Mensch published a book called Das Technologische Patt, the technological stalemate, in which he argued that there was now a slowdown in economic growth because there were not enough basic innovations to drive the system forward. So Mandel's work and Mensch's work in the 70s were the main sources of the new debate on Schumpeter's theory of long waves. And this is where I became involved a bit in this debate, together with Luc Suter and with John Clark, who were working with Parry also at that time in a project called the Tempo Project, which was looking at structural unemployment. Well, as I said, most economists thought that big depressions were a thing of the past, that they wouldn't recur. And this was reflected in the OECD, in the dominant economics directorate. They had a group of economists headed by Paul McCracken, a Keynesian from the University of Ohio. And the McCracken report was a group of Keynesian economists who looked at the OPEC oil crisis and argued that the world economy had been blown temporarily off course, but this was only a blip. And the OECD countries would soon return to high employment, to high growth, and to low inflation. That was still the orthodoxy in 75, 76, 77. But significantly, there were a group on this McCracken committee who wrote a dissenting report. And the dissenting report, at the end of the main McCracken report, argued that it wasn't any longer a question of a little flip away from the main trend, but we were now entering a period of fundamental structural change in the economies of the industrialized countries. By the end of the 70s, of course, it became more and more apparent that unemployment was still rising, the trend was upward, that labor and capital productivity were both falling, and that growth was slowing down. So by then, people began to try and find explanations. Why has the post-war boom of the 50s and 60s, why has full employment come to an end? And Keith and I, at that time, and Dick Nelson, were all invited by the OECD to join a group called STEINEG, Science and Technology in the New Economic Context. And our group was given the task of looking at how far technical change might or might not be responsible for the slowdown in the growth of the OECD countries. Because some economists said, well, yes, it's true, growth has slowed down quite a lot. Unemployment has risen, but the reason is there's not enough new technology. There are not enough new inventions and innovations coming through the R&D system, the science technology system. So the first thing that our group did, this was about 1979, I think, Keith will correct me if I've got the date wrong, but round about then, The first thing our group did was to ask the OECD Secretariat to send a survey, some interview work and some written questionnaire surveys, asking R&D directors and technical directors, did they think that technical innovation and technical change was slowing down? And rather to our surprise, the answer was almost unanimous. Nobody thought that a slowdown in technology was the cause of the slowdown in the economy. Some people had said to us, well, science is reaching limits, or technology is reaching limits. That point of view was totally rejected by those people at the coalface of science and technology. They argued actually the opposite in most cases, that there were never so many inventions and innovations coming forward which could be exploited in the economic system. So our group, therefore, in our report, exonerated science and technology from blame for the economic slowdown, and we argued the explanation lay elsewhere in the diffusion of innovations, in the inability of the economic and social system to use the inventions, the innovations that were coming forward in many areas of the system, especially, of course, in information technology, but also in biotech, materials technology, and so forth. So that was the state of the debate when Luke and John Clark Parry and I began to work on this question of structural unemployment. And since Mensch had written this book in 1975, arguing that there weren't enough innovations coming through into the economy, we started examining his work. And we had a punch-up with Mensch and his colleagues, quite friendly, although quite sharp at times. At that time, SPRU seemed to get involved more in big controversies like that than we do now. We had a similar controversy with the limits to growth people at MIT. At any rate, these were the main issues in our conflict with Gerhard Mensch and his collaborator, Alfred Kleinknecht, who's now working on innovation studies in Amsterdam University. They both worked at that time in Berlin. Mensch and Kleinknecht argued that the source of upswings in the economy, as Schumpeter had argued, was radical innovation. They argued further that radical innovations clustered during deep depression periods. And this was the most fundamental part of their argument. They said that entrepreneurs would not change their behavior if the economy was growing fast, they were okay. Why should they bother to introduce a radical change in their products and processes? If, however, there was a big depression, unemployment, bankruptcies, then they would be driven to introduce new products and processes. This was the basis of their argument, and they claimed to have empirical evidence that radical innovations had clustered in the 1830s, in the 1880s, the 1930s, and they forecast there would be a wave of new radical innovations in the 1980s, because that would be a period of deep depression. Well, Luke and I and others in our group tried to check the empirical evidence on which they based this theory. And we found, on the contrary, that radical innovations were not clustered in deep depression periods. That in fact you could find clusters of radical innovations at the height of the boom in the 1950s and 1960s, for example in the drug industry or in the instrument industry. Similarly, you could find clusters of innovation in the boom period before 1913. And so we accepted that innovations clustered, but we denied their interpretation that the cause of clustering was that they came through in deep depressions. We argued, on the contrary, using the same case studies that they had used, we argued that if anything, a depression would slow down entrepreneurial innovation because of uncertainty about the future, because of poor expectations of profitability, because of all kinds of hesitations about the market. So we disputed the Mensch-Klein-Knecht theory of clustering in those depression periods, both on the empirical evidence and on the theoretical explanation. We accepted, of course, the basic idea of Schumpeter, which they also accepted, that leading sectors and new products would play a part in the boom following a depression. But we didn't accept their idea that in the previous boom, radical innovations had been crowded out. Well, if you sum up those points and our differences, we had a theory of diffusion, whereas they had a theory that long cycles determined the nature of innovation. And in fact, I would say that their theory was not a theory of long cycles at all, because they assumed the existence of long cycles, depressions and booms, and used that to explain the incidence of different types of innovation. Whereas from our point of view, the problem was, did innovations and their diffusion affect the evolution of the economy, and if so, in what way? Well, it was at that point that we came across the work of Carlota Perez, who had been working quite independently, using Spanish language, working in Venezuela. And she had a big influence on the subsequent debate, because she introduced three ideas into the debate, which, in my view, were major original contributions and enabled us at least to diminish the force of the criticisms that Kuznets and others had made of Schumpeter's business cycles. First of all, Carlota suggested that the uneven growth of certain sectors of the economy in each wave, the tempestuously rapid growth of key industries in each wave, was associated with what she called key factors. And those key factors were commodities which had a universal availability and a falling cost and price structure. And she identified coal, steel, oil, and microelectronic chips as examples of such key factors. And in her view, the input of those key factors meant that certain industries, which she called the motive branches, would concentrate on the production of those inputs. Coal in the British Industrial Revolution, steel later in both Europe and the United States, oil, of course, in the Fordist period, and chips in the contemporary development. And she argued that these key factors were characterized by abundant supply, falling cost, falling prices, and many potential new applications. And she argued that the availability of those key factors, combining with industries that could make especially effective use of those falling cost and usually improving quality inputs, would grow more rapidly than the others. Well, I'll give just quickly 2 or 3 examples to illustrate the kind of thing she meant. If you take the price of coal during the second Condrative wave in Britain from 1840s to 1890s, of course the second wave, as I indicated in the previous overhead, depended upon steam power in locomotives for the railways, of course, but also the applications of steam power, as Nick has shown in his book, throughout the mechanization of other sectors of industry. to have that widespread combination of coal and steam power, you had to have an abundant supply of coal universally available to British entrepreneurs. And in Nick's book, you'll find data which shows the falling price of coal, not so much in places like Newcastle and Sheffield, which were, of course, always very close to the supply of coal and had abundant cheap coal for a long time. But what was important was the combination of new infrastructure, improved pumping and underground haulage in the coal mines, made possible a falling price of coal in the new rising centres of manufacturing, London, Birmingham, and of course the older centre of Manchester. Well, Nick also showed in his book that coal consumption in different types of steam engine in manufacturing applications, in pounds of coal per hour per horsepower, was falling as new generations of steam engine came into use. And he argues very convincingly, I think, that it was only with the high-pressure steam engines that you got really effective economy and efficiency in the use of coal in the applications of steam engines. So it was the high-pressure engines originally developed in the Cornish mining industry rather than the earlier types of engine, including Watt's engine. It was these high-pressure engines which made possible that kind of combination that Carlotta was talking about of a key factor with key carrier branches of the economy. And this is Nick's summary of that combination of steam power, new high-pressure engines, and mechanization and industrialization in the great Victorian prosperity between the 1840s and the 1890s. Another example is with the next Condrative wave, where Carlotta identified steel as the key factor. Rail prices were rising in the period just before the First World War and after. There were several reasons for that. One, of course, was that the steel producers learned to form cartels, and the cartels learned how to use price maintenance to keep up prices. Nevertheless, even with that price maintenance, the rise in steel prices, despite the First World War, was no greater than the general rise in prices. So that relatively speaking, the price of steel had fallen enormously compared with other commodities. And Robert Ayres has shown, in fact, that in the period from 1870 to 1910, steel was substituted for cast iron and wrought iron in very numerous applications in the United States economy. And that was undoubtedly a combination of the lower cost through the Siemens process, the Bessemer process, the Gilchrist-Thomas process, the big new processes that came in the 1850s and 1860s. The combination of those innovations with scale economies in the size of steel plants meant that steel became, in Carlotta's sense, a key factor with many, many new applications in different industries. These applications I've already mentioned in an earlier overhead, especially in construction, heavy engineering, and electrification. The low price of steel was of tremendous importance. And people like Frederick Taylor worked early on in steel plants on new alloys, new combinations of steel with other non-ferrous metals, which enormously improved the productivity of machine tools and of many other engineering products. So that's a couple of examples of the links between what Carlotta called a key factor and the rise of new industrial branches and their leading sector growth in these different Condrative waves. There isn't time to go through all the sectors, but you're all familiar, of course, with the most recent, with microelectronics, where the combination between the falling cost of microelectronics, probably greater than in any previous period of history, that falling cost and set of falling prices combined with computer and telecommunication technology into an extremely powerful combination. Well, obviously the question is, if you get these effects of factor prices falling through technical change, new factor combinations and the rise of new sectors and industries, why don't we have now more rapid growth in the economy? Well, Carlotta, I think, also contributed at least a partial answer to that question. What she suggested was that there are differential rates of growth in different parts of the socio-economic system, that technology can change extremely fast. Engineers and scientists are able to bring about sometimes orders of magnitude improvements in the productivity of the equipment that they design, and also they're able to improve the quality of their products very considerably. But before those improvements can enter the general economy and exert a beneficial effect on productivity and growth more generally, of course, there has to be a social learning process. People more generally have to understand the new technologies. They have to reorganize factories, plants, industries, markets to accommodate the potential of those new technologies. And Carlotta argued, I think rightly, that the social organizational system has a different rate of change from the techno-economic system. That you can design a new technology, but to use it effectively is another question. And so Carlotta suggested that part of the explanation for the depression of the long wave and for the time lag in recovery of an economy from a depression, the question where Kuznets said, did the entrepreneur get tired every 50 years? She said it's not a question of people getting tired, it's a question of mismatch between the institutional and social framework on the one hand and the techno-economic possibilities on the other. So she's arguing that to get that mismatch out of the system requires a prolonged process of experiment, of organizational change and political change, because you have to have new education systems, new training systems. You have to reorganize firms and industry. You have to have new standards. You have to have new conventions, norms, regulations, routines. All these things have to change. And they have a differential rate of change from the much faster rate of change in the technology itself. Well, coming to, just to finish off, you'll see that I learnt an enormous amount from Carlotta, and I think she's made the most important contribution to this whole debate. But there are some things where I don't agree with her, thank God, and it's a good thing to discuss these, and I hope that when she's here later in the year we can debate some of these things and try and find resolution of our differences. Carlotta argued that each major new technology in a long wave leads to what she called a new technological style, a change of techno-economic paradigm. Both of them very clumsy expressions and very difficult to define. What she meant by this was that if you go to the use of electricity instead of mechanical drive in factories, you have to reorganize the way you produce whatever commodities. Similarly with computerization. Similarly with the other big changes in technology. Well, that much most people would agree. You have to reorganize if you're going to start using computers. You can't just go on exactly the same old way as before. So she made this contrast, which she called change of techno-economic paradigm, between the old mass production, oil, automobile type system and the information technology new system. Well, she knew, of course, that this is an oversimplification. It's a schematic way of presenting the change. But it illustrates the point that the structure and the management and the organization of firms and industries can change with a big change in technology. The last 4 lines are lines that I introduced into her table. And the service with products illustrates one of my differences with Carlotta. Carlotta has argued that Japanese management systems exemplify that right-hand column. I don't think they do. I think that the just-in-time system, the so-called Toyota Ono system, is the last side of the mass production system, not the herald of a new techno-economic paradigm or technological style. In fact, I wouldn't look to the automobile industry at all to introduce a new management and organization style. I would look to those firms who are making the greatest use of information and computer technology to manage their operations. And those seem to me to be in different industries than the Japanese automobile industry. The second difference I would have with her, and I should emphasize that both of these differences are less important than the points of agreement, but this is like speculating about the future, about green technology, about environmental problems. Carlotta tends to argue that information technology will be green, will be hospitable to green technologies, to telecommuting, this kind of thing, and that it will save on energy and materials, which is true, of course, it can. I would argue that information technology is not yet a green paradigm. In fact, it's a long way from it. And that to reach an environmentally sustainable type of technology will take a very much longer time than she estimates, and in particular, that it will depend upon a renewable energy infrastructure, which is a long way away today. So those are the 2 of the points where I disagree with Carlotta. No doubt you'll disagree both with me and with Carlotta about a lot of those points, and I hope you'll tell me about those disagreements right now. Thanks.